All right, so troubleshooting CO2 oil booster system. Anybody, I know you guys have worked on here with CO2. Anybody else? Anybody CO2 experience? Kaz. Yep. All right, let's go on. Anybody work on RX? Got a few out there, huh? All right, so if you haven't seen this picture earlier in one of our presentations, huh? Rusty stole all my smoke, man. This is one of our old Flex 1.0 racks. The reason I can tell is the electrical cabinets all combined together. If you get to look at one of our new Flex 2.0 racks, you'll find the electrical department has been pushed to the side, and we now have a control panel. So we're getting all the controls out of the electrical part of the panel to get rid of any of the interference you might get. Plus, they run a little cooler over there. All right? Just standard 225 horses with Copeland discus, one digital and one VFD. Questions? All right, so Bitzer compressors. Everything less than a 40 horse does not have a oil pump on it. They use a slinger system. They got these cups. Make my light work. Oh yeah, cool. We got the cups as the crank turns, it's going to sling the oil around the system to lubricate the bearings. We've got a hole right down the center of the shaft, and we'll have a cup at the end of the end plate. As the oil splashes into it, this centrifugal force of the crank turning will actually draw the oil down and get our journals inside the compressor and keep them lubricated. And them journals are, has anybody seen the inside of a CO2 compressor? Yeah, you know, a regular standard crank, your journals are about this big. On a CO2, they're 3 times the size. They've got Teflon with this special coating they put on it. They're very hardy.
Excuse me, why?
What's that?
Why go to a slinger instead of a pump?
Don't need a pump. That's how they design these compressors. We only have pumps on the 40s and the 50 horses. That's even Copeland's the same way.
Why don't K-bodies have slingers?
Yeah, the old K-bodies had slingers. The old K-body were very, very hardy body, weren't they? They're 40, 50 years old out there. So it's a good design. But anyway, the cup, you'll see this cup as the oil slings around, it'll collect in this cup, and then it's sucked right literally down into the shaft as the shaft's turning, all right? You can see the difference between our normal compressor and a CO2 compressor. We've probably got 3 more holes per bolt as we would on a standard compressor, right? And that bottom one, in case you guys don't know, the very bottom one is your drain plug. All right? On our racks, we're using coalescent oil separators, wood filters. We use Temp-Right. We use Westermeyer. They are 99.898% oil separation. They are very efficient. As Rusty spoke to earlier, they're very efficient, and then they're very efficient. It works for us, then it works against us. We use Bitzer BSE 85K only in our racks. Simple reason are that's what's been certified by Bitzer, and also the HP sensors we use for level sensing in our oil reservoir and separator are also calibrated to the same oil. All right? So if you go adding different oils in there with different additives, these you conduct the sensors and you change the capacity of the oil, the switch is going to operate differently, right? Good. This is a Temp-Right. That's our reservoir. That's our separator and our reservoir here. Reservoir separator. This was a big rack. I don't know where this rack was, Rusty.
This is an ice rink in Anchorage, Alaska, with a combination booster overfeed.
Overfeed. Notice we have 4 separators because of the design at the time. They needed to have 4 for the flow of the gas. All right. So today they've got some bigger ones out there. Everybody's come up on board and is developing more technology, bigger operating capacity. So as we go forward, we're getting bigger and bigger. Standard oil reservoir. We don't have real good line sight on our sensors. Hopefully you got a better picture than that, because these are all Rusty's pictures. And if you'll notice in a lot of these pictures, they're out of focus. There's one of the 130 bar CO2 HPX, right? It's really zoomed in on the two pipe clamps in the background. It's so blurry you had to put a sticker on it. It said 130 bar.
Is that what it feels like to be run over?
All right, so from our reservoir and from our separator, we are using inline filters. These are the Hilux. We've started here in this year using Weston Myers. It's a larger capacity oil filter. It's also it's changeable by just removing the cap, but you do have to make sure you have a gasket before you do it because it will leak. All right. It's got a lot more capacity. It's a 25 micron gasket in there. This you saw earlier in one of Rusty's pictures. It's like about the size of your pinky. That little porous rock that's in there. It does clog up fast, so it's important to keep your oil system clean, your separator filters changed. I would carry an extra one or two on your truck. So if you do come across one that's clogged up and you're not getting oil transfer, I would pull that one out, put the new one in, then you can take the old one apart, clean it, and put it back in service for later on the same rack. It's kind of got nobody's ever been able to clean them more than 3 times, and then they're so clogged up they don't work anymore. And I've never heard anybody say they could do any more.
I was gonna say, like, when they get really plugged up, I just get rid of new ones. It's just a waste of time. You're not gonna get it until
You can buy these from Hillphoenix, or you can buy them online on Amazon.
they're on Amazon.
Yeah, they're cheaper on Amazon. Wow.
You can get about 4 of them for $25 on Amazon, if I remember right.
Oh wow, okay.
Okay?
I gotta tell Scott about that then.
Yeah.
Or you guys.
So we also have one coming off our reservoir to our header manifold for our compressors. And the reason we started doing this was because back in 2016, 2018, we were seeing a lot of trash getting in our separator solenoids, the oil compressor solenoids, and stopping them up, and either stopping them from working or keeping them open all the time. And a solenoid or a compressor stuck open is not a good deal. Because what's going to happen next? You're going to flood that compressor out. And guess what happens when it starts?
Boom.
Yep, you get a halo of oil out that discharge 2050 relief valve. And it goes everywhere. All right? All right, these are Hilux. Again, like I said, these are the 8mm size ones. They are small because this is an 8mm line. Guys, if you don't know, it's a very small line. It's like 5/16. All right? Again, this is the little porous rock on the inside of the filter. You can take it apart and clean it and put it back together. Make sure you put it back together the same way you took it out, right? So pay attention when you're pulling it apart because you want to be on the outside. If you put it in backwards and it goes just through the center, you don't have as much surface area, okay? All right, so these are the HP sensors we were talking about. Let's see, temporary oil reservoir with an HP oil sensor. This is a capacitant sensor, guys. So what that means is it's using the fluid, be it water, CO2, or oil. It's using that fluid to make your switch. All right, and I apologize. I had a whole bunch of show and tell shit to bring with me, but I came out last week on Monday to do a parallel compression, complete the job that I've been working with Donald on here with Arctic and Brian. Arctic? I keep saying Arctic. But I ended up staying Friday, and if I fly home on Friday, I'm not getting home till Saturday morning or Saturday afternoon. So I stayed all weekend. Same clothes, no show and tell. So I have to apologize for that. But anyway, these are our HP sensors. They are capacitant style sensors. If you take that sensor, do we got pictures? You remember?
I think the video's in this one, I'm not sure.
Okay, the video might be in here. But anyway, it's got a well that goes in the fluid. It's got a well. You saw that, right?
Kind of blind yourself over there.
Yeah, man. There's a well. This well right here. That's our well. The electronic part of that sensor will come right off. There's 2 to 3 2.5mm set screws on there for removing the sensor. You can take the sensor out. We'll go over the lights later if I'm pretty sure about it. But that well, the outside of it's your ground. And down the center is a positive rod. It's on the positive side of our DC. So as the fluid connects to that rod in the ground, it's making, and you get enough of the fluid on that rod in the ground, then you make your switch point and the light energizes. You go from a flashing green to a solid red. All right? That means you have fluid present, and now we're going to either transfer it or it's telling us in the reservoir that we're full, we need to stay full. The ones on the oil separator and the ones on the flash tank are not interchangeable. They're different. The rod's even bigger because it needs more surface area. Now, if you're on a job site 2 o'clock in the morning, Brian goes out and his separator sensor's bad, he's not screwed. He can just take the one off the reservoir, take the head off, plug it on that one, take that alarm, change it into a notice, and you're good to go. Order another sensor, get it out, replace the one on your reservoir. All right? Save that, well, because you can use that for testing sensors in the future. Yes, sir?
Do wells go bad?
They don't, unless you actually get trash in there and it gets trapped and you can't get it out.
Most of the time it's just sensors.
It's just solid steel. All right?
Some heaters in it too, they don't go that bad.
Now those are the RSDs, the heaters in it. Some of them have heaters in it because it gets very cold on this, like on the your vessel. There will rust, and you get rust on these too if you get moisture into them. And then you'll get those red lights that are solid will be blinking red. That's an electromechanical disconnect. Then you have to pull that sensor apart. Most of the time you can clean the little pyramid that's in there. So on a spring, you can clean it, clean out the inside of the center probe, put it back together, and most times they'll work. Yeah? This is a Westmeyer oil reservoir. The first one was temperite. Basically, we get the same thing. You'll notice what's the state of that reservoir? It's full or empty? That's correct, because we got green lights, and they would be flashing, right?
So what you're saying is green is bad and red is good?
Yeah, that's what they came up with, but that's a European design, so yeah.
But the old ones, if people have seen them out there, the old ones are just nothing or red.
Yep, they're either nothing or red, so you didn't even know if you had power. You'd have to literally take them apart and troubleshoot it, because you didn't know. Back in mid-2019, all of a sudden, in 2020, they showed up with a green light. Because I got a call from a tech sheet and goes, "What's the green light mean?" So I had to go online and look.
I see no.
I had to go online. I like it. It's a heartbeat. Tells you got power and you're good, right?
I like it now,
Yeah. It's a good indicator. If you have a problem with these sensors, pull them apart. Those plugs, you take that screw out right there, pull it apart. You can push that wire down and pull the plug section of that out and make sure your wires are good. All right? Even if it's been working for 6, 7 years, all of a sudden it quits working, check your power head too. You got 3 numbers on there, 1, 2, and 3. 1's your 24 volt DC, 2 is your common for power, and 3 is your switch light. Some of our older racks, and we started in actually June of 2019 was the first rack we shipped with an OMC oil module on it. Before that, we had our HV sensors on our compressors. These are the exact same switches that are in the separator and the reservoir. Anybody working on any of our older racks? The gentleman right up there was. They had a pulse width modulation combiner up in the flex combiner, right? That runs those things for medium temp. They're on 30, off 30. So it's a 1-minute cycle, and then your low temp was 5 seconds for 55 seconds, right?
He's guessing.
What's that? What was that? All right. Questions? No?
I was gonna say something, but I'm not.
Something you need help with?
I was just gonna point out what it says, definitely says, like Paul keeps saying, you see where it says switch?
Right there, switch.
Not just sensor, but switch.
Yep. And what type of oil? BSC 85K, just like those cans that we saw earlier. Don't put it in. I went to a job site, they were having problems with their oil system. And I walked up and that oil is a honey golden brown. When it's fluorescent yellow, you've added something to it. or you've put different oil in it. Fluorescent yellow is not a good color for bits of oil. So you've got a problem, you need to change your oil. HBSO1 sensor, functionality. The switches are used for detecting liquid in gas or air, HBOR detection of oil in liquid ammonia. The mechanical elements have different designs because they are optimized to different liquids, so the conductivity of liquids is different. Water, different than oil, different than CO2, right? CO2 is going to have a lower conductivity, right? Oil is more viscous. Hence the longer probes. And as I said, they have two types of switches, normally open, normally closed. We do have normally closed switches that will open. All right, we'll use them usually on liquid detection, like a receiver or a suction accumulator. Yeah. All switches except HBOR switches on when liquid is detected. This means no switch closes the contact when the liquid is detected, and an NC open the contact when the liquid is opened. And I read terrible, guys. I'm not a reader, I'm a fixer. I'm a technician by heart. And this guy tried to hire me for 5 years. But I can't come out of the field. I just love what I'm doing. But I like passing on knowledge at the same time. All right? HBOR is different. It switches off when the oil is detected. And again, the only place we'd really use a switch that switches off would be in our like liquid detection for high level, or liquid and any oil or liquid you might get in your suction accumulator. You want to protect your compressors. We've used them in series, so we'd actually shut down the system and just run the suction accumulator, pump them out, and then turn the system back on. 4 LEDs, which basically is just 4 LEDs around it. The red indicates liquid oil detection. LEDs flashing green means there's no detection, but the sensor is energized. And 4 red flashing LEDs indicate no connection to mechanical unit. And that's basically so you've lost connection to your sensor probe and your probe on your head element. All right? And when you get them, when you get a new one, you can just change the head. There's no reason to change out the entire well. All right, so this is our standard oil separator. We're going to go over the oil separator because the one thing I want to do when I leave the job site is that you guys know how the oil system works. I don't want to call 2 months later and say, hey, I replaced the HV sensor 3 times and the system's still not working. So what we have in our system is a lot of components. You got your 24-volt oil sensor, right? 24 volts. When we detect a liquid, the switch makes. Then we switch our number 3 leg on. Hold on. Nope, that wasn't progressive. We switch our number 3 leg on when the fluid's present. That energizes our OSLRA relay. That's a 24-volt coil relay. What that does is makes an input into our control system to tell us we have fluid present in our separator. So we want to move it, right? We have 2 different voltages there. We can't put 24 volts into most any control board, right? What? No, it doesn't have it.
What happened?
I don't know. You did it.
Oh, my bad.
Usually a red circle will come around the first one, then around. It's a really cool effect. But we don't have that today because Rusty messed up.
And I was sitting there clicking my finger.
Yeah.
Dude, click.
So, all right, so our oil separator level indicator turns on and energizes our OSLRA relay. That gives us an input, tells the controller to start cycling our solenoid. So next in line is our output board will tell our solid state relay. And the reason we use the solid state relay is we're going from whatever the closure voltage is, that could be anywhere from 24 to 220 to a dry contact, right? That'll go through our output board to our solid state relay. Our solid state relay is capable of a lot of pulses. So we put that in there. It's a little bit more rugged than just the output board under, even though it's like a 1/2 amp bolts. It'll just withstand it. And then that solid state relay pulses our solenoid. And the reason we pulse is we don't want to just turn the oil solenoid on and start dumping hot vapor and liquid into our reservoir, right? Does anybody know where the reservoir vents?
Your vessel.
To our vessel. So our reservoir is the exact same pressure as our vessel. And that's an important thing we'll come up to here in a little bit. If we just continue to dump that hot gas, we're putting it in the reservoir, it's going to end up in the vessel. Then where's it going to go? Come on, Brian. We talked about this. I did a surprise class and went out and taught these guys lovely facility out there at the Union Hall. But anyway,
There's an opening for tonight.
I got an appointment tonight. So any vapor we put in the vessel has to come out and go into the heating consumption. So that's going to make our compressors work harder, right? Any excess vapor is stuff we got to consume, and it's energy we're going to waste. So we pulse it. And besides, if it gets stuck, it's not a good thing. All right.
One thing I noticed though is from generation to generation, just the age of the rack, is the logic that pulses that oil solenoid has changed.
Yeah, we had the old flex combiner was set up for like this guy's old rack up here with pulse width modulation. And pulse width modulation, we would alarm after 492 counts in a day, in a 24-hour day. And then the oil separator flex combiner was set up with a 15 count. So if it called for oil and it pulsed 15 times in a row without stopping, that put us in alarm, something's going to happen, right? Then it would start cycling the solenoid every 5 seconds on, 5 seconds off, right? That's what happens.
Yeah.
So we had a compressor count flex combiner that would reset that every 24 hours. Well, we didn't have any of that when we switched to LMCs. So I asked for them to rewrite, to get one from Emerson, or Copeland now, to get it rewritten, that flex combiner. And it took about 6 months to a year, and they got it done. And then I started adding it to all the new racks. Now all we do is all we need is a signal, and we pulse on and off. Any alarms are going to come out of your digital inputs. We do alarm if your separator's high for 25 minutes. We're going to alarm, let you know something's wrong. Because if you don't transfer oil with a 300 to 600 pound differential in a couple seconds, something's wrong. All right? You don't need to change the that flex count. That flex count works everywhere. If you extend it, you're putting a Band-Aid on problem. That's all you're doing. Okay?
And the defrost.
But anyway, the new one, that's all it does. That's all it needed to do. We used to have all of our alarms. When he gets a low receiver alarm, or he'll get a low separator alarm. There's no such thing as a low separator, right? Separator's always low until it's full and we pump it out. But the low separator was actually the reservoir, because it all comes into that separator flex combiner, and anything that goes out is going to be separator, because that's how it's going to alarm. So a high separator is true. A low separator would be your reservoir. Right?
Just misnumbered or mislaid.
What happens here? There we go. That's what we want. This is our solid state relay card. You can actually pull that orange tab down. The relay card will come out. You can order a new one, put it back in, because they will fail over time. I think they're good for a 50,000 pulse count. All right?
10 months.
What's that?
10 months.
Yeah. Hopefully not.
Cycles 5,970 times 24-hour period.
Yeah, it could, yeah.
Dude, you have too much time on your hands.
Yes.
Yeah, thank you. I've said it a million times.
Yes. Yes. He goes home and does stuff. He doesn't go home and play with the wife. He goes home and plays with refrigeration. Donald is committed. This is the old HB sensor control system. I guess we keep it in here for any of the old racks we got out there prior to mid-2019. But again, let's see. We've got our HBO sensor right here. It's mounted to the side of the compressor. And again, you got your positive, your common for your power for your switch, and your number 3 out. Does this one do it, Rusty?
I think so.
Oh, there we go. That one works. So what happens is our oil sensor, our compressor oil goes low. Our sensor's going to activate and say, oh, I need oil. That's going to energize. Our LITOR relay, which is our low temp, this is low temp. Yep, low temp system. That's just our oil relay, and that's going to do the exact same thing. That's going to start our input. We got our relay. Anybody saw all those cube relays, right? When you replace them, do you buy the cube relays or do you get a better one? Put in better relays, or you buy them from the factory, put the cheapest back in?
Put the same one.
I would recommend if you do it, I'd buy a better relay. Just saying. Those relays, those cube relays, are notorious for those contacts.
Yeah, they go out a lot.
They go out a lot. There's no denying it. It happens. Everybody knows about it. So yeah. All right, so we're going to energize our 24 volt cube relay. That's going to make our input again to our PWM flex combiner for LT1. And that's going to start our pulse count of 5 seconds on, 55 seconds off. And the reason we did that with low temp is because that's a lot of pressure from 515 to 200 PSI. So we don't want to dump all that pressure in there and overload the suction on the low temp. That again makes a board output from the flex combiner, which turns on our solid state relay, which pulses our solenoid. All right? A lot of parts, moving parts, huh? So if you're going to troubleshoot this system, look at the wiring diagram and go from beginning to end. If this sensor's red and that one's not lit up, either you got a bad coil or that output leg has failed, and they will. I've seen a couple do it. Not many of them, but a couple. If that's lit up and you don't have your input, then that relay coil is probably the relay points are bad. All right? Follow it through. When you call me, you have the answer for me already. All right?
Exactly.
Then why call me?
Like, oh,
Guys,
I gotta
I
say
get
hi
calls
to you.
all day. Hey, my compressor tripped, my rack's tripped on oil. Okay, what have you looked at? Well, I don't know. You tell me. Well, first of all, how many CO2 racks have you worked on? You're the apprentice. Well, this is my first one. They told me to come up here and look at it. I said, all right, is the rack down? No. Okay. Reset your compressor. Clear your arm, reset your compressor. If it comes back on, call your supervisor. And I tell everybody this. And get somebody out there to understand the system, because you're going to hurt yourself or do more damage. Right? Right?
Amen.
I understand that in a pinch, you're going to send somebody out there, the closest guy. But you got to get a seasoned technician following him up, because he could really create a lot of problems for you if he doesn't know what's going on. All right? These are our old solenoid manifolds for headers to feed all the compressors. Those should be all 120 volt coils if I remember right. Again, what type of oil do we use in our rack?
Yeah, whoever you say that word.
What's that?
However you say that word.
Yeah. We say that word right there.
Yeah.
BSE 85K. And if you get one of our new Flex 2.0 racks and it says BSE 85L, that's just because we got some illiterate guy doing the damn typing at the factory. I have marked out so many of them things.
Does that happen?
Hell yeah, it's happened. Every rack that's come out has had L on it.
Most will.
Yeah. But anyway, use a Bitzer approved oil only, and regardless of what any supply house tells you, Copeland has certified those discus to work with that oil. Okay? Because we've had the calls and we've had the conversations with everybody. I think everybody's finally come around and accepted it. So, where's everybody buy their oil at? Get your camera ready. Call that number. Now, all these distribution stations around the country, they can get it to you, and they can get it to you quicker than we can. If you need to and you can't find it, call us up. We'll send you the oil, guys. But this will help you out in a pinch. Good to go?
Yeah.
All right. So, everybody understands the old pump system. Me, I got a little trick. I used to take the cap and put it under the end of the can and tilt the can. That way I could get a little bit more oil out of it. Don't pump vapor into my system. And I actually watched a kid pump a gallon of oil into a reservoir that was at 515 PSI.
I'll hire him right now.
That guy's well strong motherfucker.
All right, so 45 minutes.
That's Andy's show.
I ain't messing with that guy.
45 minutes to get that can of oil in there. And when he was done and he was wiping the sweat off his brow, I go, you know, me, I would have went ahead and just vented it down to a little bit of pressure and then done it. Okay? And he goes, thanks for that. I said, hey, you learn from your mistakes. All right? And I had one of our FSCs call me up and goes, yeah, the contractor put 5 gallons of oil in the rack. I said, well, that's good. He goes, no, it's not running. I said, what? I said, wait a minute. Where did he put 5 gallons of oil? Oh, he put it in the reservoir. On a standard Audi rack, that reservoir holds 2 gallons. Where did the other 3 go? Anybody got an idea? Where does the reservoir vent to?
Oh, I had a vessel.
Vessel, right? 3 gallons of oil were pushed up that 8mm vent line and into the vessel. I told the guy, I said, well, look, I said, when you start that rack, you better pay attention to your oil level in your compressor because it's coming back hard and fast. Yeah, they paid attention until they didn't pay attention. When that oil hit that valve plate and went up to the gasket, it blew the gasket off of the discharge valve. Yes, sir. It happened to me 8 months later. What I did was I turned the farthest case on and let the rack start and just let it run for an hour like that. On and off, on and off. But that oil went out, came back, because it's going to come back fast with CO2. It's very miscible. Okay? Everybody knows what miscible means, right? The oil molecules and the CO2 molecules are very attracted to each other, and they go hand in hand up the system and out the system. Okay? All right, so back before we were using Crewans and OMCs, we were using the HB sensors on our medium temps and the OMBs on the low temps. The OMBs were rated low enough pressure. We had to wait until vendors out there developed high enough pressure switches for us to utilize them and put on our systems. All right? This sensor you'll have a green light for normal operation. Your site level's full. When it hits 40% and it's there for 10 minutes, it's going to start the fill light, which is your yellow light. You have 10 minutes, you have 2 minutes to fill, all right? If it does not fill in that 2 minutes, something's wrong. But it'll also trip and you'll get a red light. That red light will come on. The compressor shuts off, it goes down into cool down mode. It will restart again and it'll try 5 times. Then it locks out. When that red light's blinking red, it's locked out. The only way to reset it is to cycle the power. Okay? If you locked out, I would start looking at my oil system, especially those inline filters. Something's wrong. But it's not going to be just low temp. It's going to be all 4 compressors on that rack because they're all off of one oil line. If in a pinch, if you don't have another inline filter, you can't get it cleaned anymore, pull that stone out and just put it in there without it. It's better to run the rack than to not run the rack, right? And get another inline filter as quick as you can. So if you do go on a call and got a call at the compressor, you got a compressor oil trip, you get up on a roof and the compressor's running, what happened? Come on, what happened? It filled, it tripped, and then it started on the 2nd to the 4th time because it locks out length. on the 5th, right? Don't you throw that ball at me.
No, that's why I like you have it, throw it down.
Oh, yeah, that's a good idea.
Next time you don't answer, throw, that's right, throw a ball at it.
All right. Any questions? OMC works exactly the same. The same parameters, the same everything. Works identical. Oh, and if you didn't know, for this switch, if you pull that line right out over there, that's your power line. You can pull right there and put it back in. It's two connectors. Or you can just do like most of us do, turn the pressure switch off, that kills the power, turn it back on. Then you recycle, okay? Here's an Emerson OMC oil switch. Same thing. We got a green light, yellow light, and a red light. I gotta tell you guys, nowhere on the top of that switch does it say this is a step. Okay? We had one sent back under warranty because it broke the yoke up here on the flange. The flange broke. Guy sends it back. Has a boot print right on it in oil and dirt. I called him up and said, I can't warranty this. He goes, why? I said, because it's not a step. This was on the outside compressor. He used to step up and look at the VFD. Oh. Which we used to put the VFD really high in the air. Anybody familiar with those?
Oh, yeah.
Order from Amazon. Yeah, Walmart crew hated that. I was teaching, I had Walmart start up 3 weeks ago, and I kept saying Amazon. They go, we can't buy from there. But anyway, order a male-female 9-pin. Take this display off, put it in your hand, plug the cord up in there, and you can do it right here. All right? Makes it easy on yourself.
Yeah, I never thought.
Now on our new racks, when we redesigned the Flex 2.0, I got to have some inputs on design, and I tried to make it user-friendly for service, because that's what I deal with. They did 29 of 30 suggestions, and one of them was dropping that drive, as well as make a lot more operating space for you guys to get your fingers into, unless it's a mini Flex. So again, you know what rack this is, right?
Yeah.
You know what rack this is? Anybody got Trader Joe's out here? This is a Trader Joe's rack, guys. The reason those compressors are oriented the way they are is because the discharge for this compressor is on the wrong side. So the oil switch goes backwards. And we had to mount it like that. That's a 4 and a 9.
Go ahead. I'm just saying, that slide's not supposed to be in there. There's some missing slides and slides in here that are not supposed to be here somewhere.
If you don't know, Rusty did this for me. I don't do this. Rusty does this stuff. I'll talk about it. I'll share my knowledge with you. I got to share it with somebody. All right, so going back, we've got at 40%, yellow light comes on. At 60%, we shut off, okay? On the OMCs, don't go by the sight glass, and also on the Crewons. The Crewon is an optical switch. It's 130 bar rated. That switch is, if you go at it, it turns 90 degrees. There's a plate with 2 holes. And then the optics is behind it. So the oil representation in the sight glass is just telling you there's oil there. That's not the true level of your compressor. That's determined by the switch. And they're the exact same, 40 and 60%. All right?
Which control again, do we gotta cover up the size?
So last year at Christmas, we've been pushing out Flex 2.0 since June of last year. Last year at Christmas, Crewon came back to us and said, look, we need you to cover the sight glasses on the Crewon modules because they're optical. So what does that mean? What's going to affect it?
Light.
Sunlight. Makes it think that it's empty and it continues to fill. You can put electrical tape on there. It makes you feel fuzzy and warm. I would come up with something more permanent because that tape's only going to last for the first couple months before you actually start getting a little oil in that glass. And it's just going to peel off.
Have they fixed that?
Yeah, they're going to design a cap to go over.
Oh, a cap? Yeah. I guess so.
Yep. They will have a cap. I've found that some of the metal plugs for covering up the 3/8 electrical knockouts, the ones with the metal tangs, you can bend them and get it to fit in there. That works pretty good. Compressor with Emerson, compressor with Copeland OMB C oil controls. LED codes when lit. Green, 24-volt power is supplied to the OMB, OMC, and 120 volt or 208 power supplied to the OMC. My radio. Yellow, float sensor determined that the oil level has been below half, 40%. Sight lasts for about 10 seconds. The fill solenoid has been activated, and it'll be activated for anybody remember how long? A maximum amount of 2 minutes. And then it's going to lock out and trip. But it will recycle 5 times. Because if you go up there, we'll come up there in a second, right to tune of the night, oil level has remained below that half sight last for over 2 minutes after fill solenoid has been deactivated or been activated. Alarm has been activated and compressor is prevented from operating until an oil level reaches half cycle last when the alarm automatically resets 5 times. Red flashing. There has been 5 auto reset registered within a 30-minute period. Alarm circuit is now locked on and compressor is locked out. And how do you reset that? Power cycle. This is our electrical wiring diagram for our OMCs. If you do a conversion, guys, from HB to OMC, you have to also go into your alarms and make some changes because we're looking for a closure on one sensor and looking for an open on another sensor. So on an OMB, normally the normal system is de-energized, so it'll be looking as an open and closed as active. So make sure you make them changes. You're going to delete a bunch of stuff in there. Also, you're going to get rid of your pulse width modulation, your compressor count, all that stuff. All right, so our switch energizes. After 2 minutes of calling for and not filling, then we're going to energize our LTOR1 relay, which is our oil trip relay. Say we've got an oil trip. Or today on some of our new ones, you'll get a proof fail. Same thing. Because we actually wire our oil switches through our safety circuit. And our safety circuit has to be closed at all times for a controller to bring it on. If it's open, you're not going to get that compressor to cycle. So we've seen this picture earlier.
Yes.
In case you don't know, 24 volt DC, 120 volt AC, until the factory throws a little ring to the finger and you get red 24 volts. But they won't have a little diode on. So be careful. Don't do like Rusty and burn out a relay and pull it out and grab the one next to it and stick it in there and burn that relay out because he stuck the 24 volts in the 120 system.
I learned more from what I do wrong.
It only took 2 relays, but he learned.
The whole time I cussed Hillphoenix out.
Changing out a temp-rate cartridge. All right, so temp-rate. One thing I got to say about temp-rate. The sealing of this, the top on this unit, is not by pressure per se. It's by an O-ring on the throat that goes inside. That's your sealing surface. I think we come up here. When you take these off, you're going to pop them, open it up, and you're going to find a spider in there. You're going to back out these 3 suspension bolts, which actually keep it from rotating due to harmonics or just vibration. You're going to unscrew it counterclockwise and pull it out. The new filter will have an O-ring, and almost every time you take these apart, what's that O-ring look like when you pull it apart?
Gone.
It's either gone or it's expanded out, right? Because it's filled up with CO2 and oil and has expanded, okay? So that's a good indicator. You should, if you go up to a service call every few months, I would do a differential pressure check across those separators whether it's Temprite or if it's Westermeyer. If you see 0 or greater than 12, I would recommend changing those filters, guys. It only takes 25 PSI differential to blow that filter apart that we saw earlier. 25, it's not a big deal. If you get a dirty filter and you get something coming out of defrost, what happens? Your second compressor comes on, right? Because your suction pressure is going to rise and you're going to get a big influx of mass flow on your suction line. You're going to push that much more through that filter, and that's when you're going to have a really great differential. And there's not a lot of surface area on the inside, and it'll blow those filters apart. Temprite, you always get a new O-ring. I would recommend replacing it. Oil it up before you stick it down in the throat so that you don't pinch it. Be careful. Torque them to 50 pounds. Or as Rusty says,
2 ugly nuggets.
2 lucky chucks. All right? 50 pounds.
Actually, the guy at Westermeyer approved 2 ugly nuggets.
Yeah.
I called him, I said, can I just do 2? He goes, yeah, that's good.
I've always used my arm. I tighten it until it stops. Anyway, chain gun on Westermeyer. Westermeyer's a little different. Way more bolts. All right? Me, I used to service Mycoms. Anybody familiar with Mycon compressors in the ammonia industry? Spring-loaded heads. So if you got a flood back of liquid, that head would literally lift off the plate and it would bypass and the head would reseat. Well, the trick to taking them apart is to take 2 bolts out, put 2 jacking screws in and bolts on them. Break all the other ones loose and then jack it out slowly, right? That way, when you hit it with a hammer and it's been stuck for a couple of years, it doesn't just bust off and take your face away with you. I still like to... What the hell? How do you tell me, Rusty?
You skipped right through it.
You were like going ahead.
Wow, nobody said anything.
We didn't say a word to you.
Yeah, I know.
No, we just mesmerized.
I like to leave 2 nuts on there, even though I know mentally that there's no pressure in there. I like 2 nuts, and I like to break it loose. Then I'll take the other 2 nuts off. It's just a safety thing that was built into me from years ago. I used to do service out here. I worked for Market Refrigeration at one time, MRS, back in the early 90s. I don't think Bill's around anymore, is he? Yep. But anyway, you're going to pull back. I call it a strong back. People call it a shuriken. But you'll notice that it rotates counterclockwise to get the little tabs into the screws. I complained about that because what happens is when you take it apart, put it back together, and you start tightening that wrench up, it pushes those tabs away. Well, they have changed that now. Now it's clockwise. Now the tabs are on this side. And eventually you're going to get a nut, guys, welded on right there to help get that thing out. Because it's tough when it's hot. All right? So you're going to take these, you're going to loosen these screws. They send you nuts. They send you new ones with the new crush up washers. I personally would not take them out because you're going to drop one.
I get it.
It's inevitable. Then what you going to do?
It was a bitch.
You're going fishing.
It's a bitch.
You're going fishing. It's the same as when you pull that out and that donut goes in the bottom. You don't leave it in there. You got to go fishing and find it, right? Because if you leave it in there, where's it going to end up? If it's out, it's going to end up in your condenser. If it's outside of the separator, it can end up in that discharge line. All right? Plus, it's going to just start falling apart over time. Westermeyer redesigned their filters about 2 years ago. They used to have hard gaskets that were glued on. You remember those?
Yep.
That gasket was stiff. It was that hard. Well, they redesigned it. They didn't say anything to anybody. We all of a sudden started getting these rubber donut gaskets. Well, these rubber donut gaskets, you can take them with your fingers and pinch them shut. What's going to happen to them under compression? They're going to compress, right? They never changed the mounting point either. So there's actually a little bit of room in there for movement. And what we started seeing once we got above 93 degrees and 238 on the discharge line, we would get a lot of bypass. right? And everybody's seen it. You get those sensors that come on in the summer and they never shut off. Well, that's what happened. What happened was we were getting too much bypass air, and once that switch fired, there was enough heavy vapor-laden oil in there that it kept the switch fired. And it would not shut off until you got down to about 1100, 1050. Those were hot, solid numbers you could use every day.
It was amazing.
Yep. When it cooled back down, and we'd go back to normal operation. So we also determined at the time that the sensor we were using, we've since changed it, was very sensitive. It went hypersensitive. Once it got out of the 80 degrees centigrade range. And that was what was causing that issue. It wasn't the pulse count, as was seen on some of the podcasts. It was not the pulse count. It was not the size of the oil valve. If you change that oil solenoid and you put a 4 millimeter oil solenoid on there, there's not a 4 millimeter solenoid rated for 120 bars. Yes, sir.
But I saw it on the internet.
Yes, and everything you see on the internet's true, right?
That makes sense, because we had that problem over at the store. That same problem. Kicked my butt.
Well, I answer calls from you guys all year long, all day.
I thought it was the oil count was messed up. I thought everything. I was getting my butt kicked on that.
So what I did to diagnose this problem and determine what it was, is I had one that was doing it. We shut this rack down. I pulled the discharge line going from the separator to the reservoir, put it in a can, started the rack back up. Open up that valve. I got 8 ounces of oil, nothing but vapor, and the switch was still lit. So don't go by what you hear on the internet. They're guessing. They obviously didn't do any diagnostics to determine what was wrong, right?
Because they had those rubber ones in
Yes,
there.
they did.
I changed like a bunch of filters.
You ever notice when they came out, they looked like cauliflower sometimes? Yeah, they had a problem with CO2 impregnating them. If you set them out on the table, anywhere from a day to a week, they would go back to normal. Hell, I pulled one out and it was popping in my hand.
Yeah.
The CO2 was bursting out of the rubber. But they come out complete form. They found a coating that's working. It's gone away. I've only seen a couple little bubbles here and there if the coating didn't get into the rubber, but they fixed it. So these are very good. They're very efficient. But there is less surface area inside a Westermeyer than there is a Temporite. So if you happen to get before you do an oil change, your separator change, have you check your filter, open it up, look at your gasket. Make sure you don't have one of these rubber gaskets. Did you see that? That's put it on, took it off. It looked like that. It crushed it. Just trying to stop it from sealing. Their groove wasn't deep enough for an O-ring. They redesigned the groove and made it deeper, but it still wouldn't seal. I think I've got a rack up in Seattle that does have an O-ring in it because that was the only one that would seal it. The metal crush ring wouldn't. And I'll tell you right now, that metal crush ring, they say it's a one-time buy. I was stuck, man. We put it together, we couldn't stop a leak, and I pulled the thing out, kept it together, flipped it over, put it back in, and got it to seal. Put some oil on it, got it to seal, and ordered a new crush ring. But don't think you're out of the game just because you try something. Think outside of the box. You got to get your customer right. You can't walk away and say, hey, I'll see you Tuesday. Got parts on order. Think outside of the box, man. Try something different. If you find one of those O-rings, just call Westermeyer or call our factory. We'll send you out a new crush ring. These are the crush rings. They're a pain in the butt to get out. Let's just say that.
Really bad.
They're really bad. Yes.
Not a fan.
If you thought getting the gasket out of the head of a Sporlan filter was tough in the old days when they really got compressed and had been on there for 30 years, that will break your bones right there. All right, so Westermeyer oil separators, when you put these back on, you will torque them. Start at 25, start pattern all the way around. Guess he didn't like it.
He's on call.
Oh. and then go to 55. If you still have a leak at 55, what are you going to do? Tighten it a little more. Tighten it a little more. Right? Hey, get it sealed. Get it working.
It's actually a West Myers spec.
Yeah.
55 foot-pounds, if it leaks, tighten more.
Yep.
Not spec, it's a suggestion.
Remember to tighten the lid in a star pattern to 55 foot-pounds. 2 luggage hoses.
Huh?
2 luggage hoses.
Yeah, 2 other guys.
Again, deja vu. Somebody else showed this earlier.
I had one do that. I had one do that at a store, and I even had to take all the oil lines off and blow them out because the stuff got stuck in there and would not. I couldn't get no oil to feed through my system.
I would tell you right now, if I had one of these happen because all that glass and fiber gets out, I would actually pump or drain the oil out of that somehow. With one of them electric oil pumps, get it out of that reservoir, separate it, get it all cleaned out the best you can. Because you're going to fight that for 2-3 days.
We fought for weeks.
Yeah, well, it's very possible.
You have the low pressure floats be blowing these out.
But if you'll notice, when they separate exactly like that every time. I think when they tack weld it, that weakens that piece, that joint.
And when they do that, they're hard as hell to get out too.
Oh, yeah, they are. They got to come up through that hole. And the only thing you do is stick your fingers in there and pull it out. Till you get out enough to get a damn wrench on. Fair play. Again, the same thing. If you could look, you can almost see a bubble right there. That was it.
Thank you.
I got some. That's not the one I did for you. There's missing stuff, and I have,
Well, that's the last one you sent me.
the one I had on the thumb drive was different. So if you wanna put this in, I can show you.
It's like half an hour.
Huh? Or you can show that wiring diagram and video and stuff.
Take a break real quick, guys. Yeah,
They're gonna go to the.
you know, Donald, he's a lot of little.
A what? Pen? An ink pen? Oh, you wanted, you should have showed them the survey.
Oh, we're good on this one. They're all gone together.
Yeah, I was,
Vacuum or something.
I feel bad because some of those slides aren't supposed to.
Well, that's the one you sent. That's one.
Yeah, I'm like, that's not the one I thought I sent you. Where do they have these? One on his thumb drive. There's only one. You wanna do this, or are they leaving
Go
on
ahead.
you? You're gonna do it.
No, put it up here. I'll do it. You gonna use a pin now?
Yes.
You okay, Mario?
All right.
Click on it.
We'll give everybody a couple minutes.
The video in there with Bailey.
You got a stress compressor.
I'm gonna go get one of those as soon as they leave here. They have plastic. Where they go? There ain't enough on it? I have a green one of these. It's like 10 years old. And they were green instead of the ones that are gray now.
Why does Brian do that? He can't make it work.
Huh?
He can't make it work by the time. Come on in.
Is it starting?
Oh, no.
Oh, no.
We're middle of the way.
Oh,
We got to come up the street and turn around, come back.
okay.
That one with the circles that was missing?
All right. So let's see what Rusty forgot and added into this one. All right, so here's the two HB sensors, right? This is an HB SC2. That is our vessel sensor. You can tell the difference when they're side by side. The oil sensor's about this big and the CO2 sensor's about this big. Is there a picture? Is there a picture?
Yeah.
That is our HBSO1. Today we're using an HBSO2. The HBSO2 is just less sensitive at higher temperatures, okay? There's the difference in the sensors. As I was saying earlier, you got an outside, your outside of your well is your ground. And if you'll notice, you got an insulator here, and then a rod that runs up the center is your positive rod. You'll see another insulator right there that keeps them isolated so that your fluid actually makes your conductance switch. Okay?
So I got a question, going back to the sensor. How critical is it to be grounded to the vessel for proper reading?
It's,
We always, sit there and wrap that Teflon and put a little coat on it.
it's not grounded. It's not the grounding to the vessel. It's the actual sensor inner probe and outer probe that's important. That's your conductance.
But, can I add this? Teflon is a lubricant. It is not a thread sealer. So when guys are putting on rounds and rounds of, they're actually creating mates more so. Teflon should be no more than 2 wraps, and because it's more of a sealant or a thread lubricant than it is a sealant.
I didn't start up on a rack, and I had some downtime, so I played with it. And what I did is I took an alligator clip, put it on the outside of the sensor to ground, and it worked. Other than that, I couldn't get the sensor to work, so I had to take the sensor out, remove all that Teflon from the fabric, and put it back.
Yeah, but it's not dependent on the ground to the chassis.
Your assumption is the Teflon was an insulator?
Yeah.
Ground?
No, in case you guys don't know, we send out a roll of Teflon and a bottle of Permabond. The Permabond is the sealant, the Teflon is the lubricant. Use them in conjunction with each other, and they will work to seal any of your fittings that you utilize. I have another name for it, but it's not appropriate for this room.
These are Paul's nail. Paul and I are doing this together.
This is Rusty and his granddaughter.
Stop. We'll go down a little bit. Stop.
Green lights. See 'em?
Go down. Stop. That's good. Alright, 24 volt. Perfect.
All right, any questions on how that operates? These were originally, hey, what's up?
Can I add something to something you said earlier? So earlier you heard Paul say if you wanted to test them, you could put them in oil. If you save that sensor,
Yep.
and then you'd have one, anytime you think one's bad, you could put it in there. That was lawnmower oil. So it works. I was last year when I was here, I did it with vacuum pump oil, and I did it. And the only oil that doesn't work if you're testing, like Paul said, is 2-stroke motor oil. I don't know why 2-stroke doesn't work, but it wouldn't work at all. But all the other oils, just for a test, you can't run
Yep,
it.
just for a test to make sure. See, if you have the well, you can grab a cup of oil, vacuum pump oil, go up, take your sensor off your reservoir or your separator if you think you've got an issue with it, put it on the probe and stick it in the oil and watch it fire or not watch it fire. And if you have an issue where you've got intermittent problems, you got a failure or it's overfeeding or something, you can't figure it out, it's intermittent. Dunk that switch up and down. Make sure it fires every time. Make sure you get 24 volts. All right, just because the light comes on doesn't mean the switch is going to make the closure to 24 volts. All right?
Get a spare well.
Yep. Anybody not understand this? If you don't, I can explain it again.
Oh, I know.
What don't you know?
Explain it to me again?
What's that?
Could you explain it to me again?
Sure, why not?
It has some circle.
He wants to see his circles come up. All right, so this was supposed to be on my presentation, but apparently he kept it for his for later. Again, I think I was set up.
Set up for failure.
All right, so again, we have our OS, and let's go over the refrigeration switch and the oil reservoir switch work exactly the same way, but they've only got the 2 relays and 1 input. They don't have the rest of it, the flex combiner that cycles your pulse count card, your solid state card, and your solenoid, okay? All right. So we're gonna have fluid present. The switch is gonna go from flashing green to flashing red. That's gonna energize leg number 3, which energizes our OSLAR relay, oil separator level relay alarm. That's gonna make a closure to our input board through our cube relay. Our cube relay is green, will turn on green, it's 24 volt DC. If you've got a green light and you open up your flex, when you troubleshoot this circuit, you have to have your separator flex combiner open. Because there's a separator high in there. If it doesn't turn on when that light turns green, then you're not making your input, or you got a bad board input. It's either going to be bad contact on that OSLAR, or it's going to be bad input. If it's the contact on the OSLAR, you got a spare one next to it, move it over. Okay? Move it over, save yourself some time. That's going to start our flex combiner, which is going to start pulsing our relay output board on our 8RO board, which is going to turn on our solid state relay, start pulsing our solenoid. So if I've got a green light and no high separator input, what's the problem?
You're empty.
You're empty? No, we don't have the empty buttons.
You said green light?
So that energizes, turns from flashing green to red. That light turns green, but I don't have an input. I don't have this input into my flex combiner, and I don't see a high separator. What's my problem?
The relay.
The relay. What's not making?
Contacts.
Contacts, guys. So you don't have this input. You have to have that contact make to get your input. If it's not making,
If my rack has been running for 1.5 years, isn't it my program's bad?
no. Okay. This is something okay.
I was trying to set you up. That's one of Paul's big things.
Yes.
Go.
Guys, I write the programs. They work everywhere. If you start changing them, whose program is it?
Yours.
It's your program now. Don't call me up and ask me what's wrong. Because I can tell you, I get called out to look at old jobs. You know what's the first thing I do is?
Look at the program.
Look at the program and put it back to normal. I put the whole system back to normal startup operating parameters. Guess what happens almost all the time?
Fixes itself.
The rack fixes itself. Those daggone refrigeration fairies are at work. And they have done their job, right? You have a problem? Go home. Come back in the morning. The refrigeration fairies will correct that crap overnight.
Talking about our Berman problem. That's
Okay,
what I'm
so-
trying to get you to.
So we were dealing with a ShopRite up in New Jersey. They kept calling us. I went up and looked at the program. First thing I saw, first place I go is into the set point change file. Because you can't delete that. I want to know what you've been doing for the last 6 months. Well, the first thing I saw was max superheat alarm, max operating pressure, minimum superheat alarm, a whole bunch of alarms were just taken out. They said they were getting nuisance alarms. I'm going, well, those are important alarms. Why would you change them? Why would you take them out? That's where it started. What they were having was floodback problems. But anyway, that led to, they kept getting intermittent trips and nobody could figure it out. Okay? Rusty and I wrote a how to troubleshoot the electrical schematic because they couldn't read the schematic. You know,
On the oil system.
on the oil system, when clear gas in and out, you're going to put a TV screen on there to show what's inside. Right?
Mm-hmm.
Okay. 3 months they fought this. They kept telling us that nobody knew what they were talking about. It was not a relay problem. And I was actually told on the last phone call, if somebody tells me it's a relay problem, I'm going to get him fired. Which he couldn't. But anyway, I said, Eric, I said, we replaced the solid state relay cards because they said that was the problem. I said, I think it's an intermittent issue between the sensor Sensor and the relay. Well, they put all new relays on there. I said, has anybody sat down and watched that thing work and make sure that every time it fires, the flush combiner turns on? No. So they went out and they took a probe and a bucket and they did it 30 times. Out of the 30 times, it fired 26 times. Where was the problem? Right there where we told them the first time. But everybody wanted to argue. They called me, they called Rusty, they called Pete Ferretti, who's a very smart engineer in our company.
One of the best.
Everybody, you know what we were telling them? I told them what he said, what Pete said. We all told them the same thing. 5 pieces. It can't be but 1 or 2 of them, or 1 is the problem, and it's intermittent. Just because that red light turns on doesn't mean it makes a closure. And that's exactly what it was. That store, we haven't had a problem with it in 2.5 years.
But can I add to that just a second?
Yep.
If a rack is running a month and a half, and nobody's been in the program, don't call Paul and waste his time saying, I have a bad program. You have a bad input. You have a bad transducer. You have a bad input. It's not the program unless somebody changes it. You get those calls, we get those calls. Program jacked up. How long's the rack been running? 1.5 years? No. It's the hardware.
So to add to that story, I looked at all the case controllers, and from startup, one of our FSEs and Emerson, Copeland, Emerson at the time, were on site. All the settings in the case controllers were wrong. So I volunteered out of the kindness of my heart to go in at 10 o'clock with one of the techs, and we're going to go ahead and flash all the programs down, change all the set points. I hit send to, it went down, it came back. When you do that, what do the case controllers do after you send them new data? Anybody remember? No?
Reset.
They reboot, right? They shut off, come back on. Well, guess what? From midnight to 5 o'clock in the morning, me and the other guy kept resetting the computer and trying to figure out why none of them case controllers would come back online. At 5 o'clock in the morning, I get tired of it. Guess what I broke out?
Look at you.
You're damn right I did. I broke out that oscilloscope that I carry. I go to stick it in the wires. As soon as I tightened them, boom, all the cases came online. The screw was loose. Then they all wanted to say it was my fault that all the cases wouldn't come back online. I says, nope, that problem was there ready to go, waiting to happen. I can send data down every day and not have an issue. What else is on here, Rusty?
That's it.
That's it?
Those are the
That
things
zip
that-
guy that was driving me crazy.